Hey guys, I'm starting a new series on this channel because I'm very bored. It's basically a series where I solve random integrals every day. And today we're going to solve this integral, cos of x to the power 4. And it might look pretty simple, but it's fairly tricky, trust me. So I'm going to take you through a pretty detailed but fairly easy method of how we can go about solving this. All right. So first, we know that cos of 2x equals 2 cos square x minus 1, right? So that means cos square x equals cos 2x plus 1 over 2. So now we can substitute this into this. So this is nothing but cos of 2x plus 1 divided by 2 whole squared dx. Right, so both of these are the same integral, but they're just written in different ways, and this makes it easier for us to solve it. So now we can just do a bit of algebra. So this is nothing but so let's see, cos square of 2x plus 2 cos 2x plus 1 over 4 dx. All right, so we've basically got ourselves three separate integrals to solve now. So this can be written as we take 1 over 4 out because it's a constant, and so it'd be 1 over 4 times the integral of cos square 2x dx plus 2 cos of 2x plus the integral of 1 dx. Right, so this is what we've got ourselves with. So three separate integrals, and we solve them, one by one, and then multiply them with the constant 1 over 4, right? So it looks pretty simple, right? So let's start with these two, and then we'll get back to the first one because the first one takes longer. All right. So the last two are basically 1 over 4, and we know that the integral of cos of x is sine of x, right? So we can basically write that using u substitution. We basically get 2. 2 goes out, so we can bring that here, right? And then we have sine of u, and then because it's 2x inside, we get du over 2, right? And then these cancel, so now you just have sine of 2x over 4. So that's your first integral, right? Okay, now we'll go to the second one. We already know that the integral of 1 is just x, right? So that would make so I'm just going to put a line here, and then so the integral of this, which is 1 over 4 of 1 dx, is just x plus 4. I mean x over 4. Right, so we've got two of the integrals out of the way. So now we have to solve, of course, the hardest one. So we're going to do this one, right? So we have cos square of 2x. So I'm going to draw an arrow. So we using the same formula that we derived over here, we're going to rewrite this in that form, all right? So it says 1 over 4 times cos square x equals cos of 2x plus 1 over 2. But notice that in the place of x, we actually have 2x. So then this cos of 2x would basically be 2 times 2 of x, which is cos of 4x. So now we can split this into two more integrals, right? So this is basically 1 over 8 times cos 4x dx plus 1 dx. So now we have simpler integral. We made this much simpler, right? So we can easily solve this. I'm just going to draw an arrow. Right, so this is basically 1/8 times the integral of, what is it? Sorry. I'm going to do this a bit higher because I'm running out of space. I don't want to erase everything again, so 1/8. So the integral of cos of x, as we know, is sine of x, right? And then we use u substitution again. So we basically get sine of u and du by 4. So this is basically small mistake, cos of u du by 4. So this is essentially sine of 4x by 32. We've got that out of the way. And then finally the last one is pretty simple, right? It's just x over 8. So now we have the 4 terms that we want. We can put them all together. So add them all up and we get the final answer as x over 8 plus x over 4 is nothing but 3x over 8. So 3x over 8 plus sine of 2x over 4 plus sine 4x over 32. And of course, last but not least, the constant of integration. So that's plus c. I'm going to put that in a bubble. So that's your final answer. Just a lesson to know is don't be fooled by an integral. I mean, that looks very simple, but it led to all of this. So yeah, never be fooled by an integral. So we finally arrived at our answer. You can check through the work if you see there's something wrong, but I'm pretty sure this is right. So yeah, I guess that's it for today. I'll probably take up another integral tomorrow. This is reasonably simple. Probably take a harder one tomorrow, so you guys get, better exposure of what calculus is actually like. And eventually, I guess in like a month or two, we'll get into stuff like, applications and stuff, parametric functions, Taylor series, stuff like that.